how we are going to be working together and how we are working together, and a little bit of very highlights of our software product. Hopefully that will set the stage for Peter, that is going to be presenting you and also demoing a SCALE.sdm model. And following that, we'll have a 5 minutes Q&A. And then right after that, we'll have about 20 minutes focusing on the SCALE results. And then at the end, we'll have a discussion and a little bit of Q&A, and hopefully closing the session. And again, thank you very much. You're going to be all muted, or you're already muted. Please mute yourself if you're not, and so we can get on with our session. So a little bit about SCALE GmbH. SCALE is established 2012. A little bit of the history of SCALE. Some of you may know. SCALE was part of Dynamore until about last year, and then SCALE was separated from Dynamore due to Dynamore was acquired by ANSYS. Therefore, SCALE is its own entity, but the SCALE product software started in 2012. 4 branches, as you can see, where the auto industry is strong, and subsidiaries in the US and India, and also, having distributors everywhere. But 60 people, and right now in the US, we have started recently, and we are growing. And as you may have seen in the LinkedIn, I'm hiring at this point for our office in the US. So as you can see, our presence worldwide, we have distributors and also our SCALE office and eSavant. Myself as a CEO of the eSavant and a COO of the SCALE, representing SCALE in the US and North America. So a little bit about eSavant and SCALE, and that gives you a little bit of the better, clear picture. So eSavant is established in late 2022, and my mission is to use my 34 years of experience for the digital transformation, as I've seen where are the niche areas that product design development needs new entities and new areas. And SCALE is filling one of those areas that I think it's definitely is a key enabler for the virtual product design development, and bringing efficiency to the product design and development, and reducing cost saving. The other product that also, I'll be having a couple of webinars coming soon. It's going to be for engineering. It's a material modeling and material characterization for different type of components, especially plastic and composite. So setting the stage for the SCALE, why SCALE is it's important in this marketplace. As we know, virtual product design development is growing every year by year. And this is some of the historical money that is spending on the virtual product design development. And we can see how it's growing, the virtual product design development. In order to enable virtual product design development, you have to have the tools that these tools can provide environments for the growth, and also make sure the organization of this massive data that is getting into the product design development is organized. The key areas that force companies to use SDM solutions, and SCALE could be one of the leaders, is getting to the AI ML solution and optimization and CA-driven product design development. As we can see, this is growing. Myself, I spent last 10, 15 years in this area on the AI, ML, and CA-driven product design, development, and optimization. Also, ever-increasing safety regulations is causing the industry to find the ways to organize themselves and be able to provide solutions during the virtual product design development. Also, because of after the COVID, synchronizing workspace in a different part of the world and using cloud space environment is really an enabler for SCALE to be providing an environment for the virtual product design development. So what do we have as far as the SCALE? Our product has 3 modules, key modules: projects, SCALE model, and the SCALE results. And today, Peter is going to be talking about the SCALE model and the SCALE results. Also, as a part of the completing the stories, SCALE provides services for different type of software, especially in the AI and AI, ML, and IT, and also consulting, helping companies to grow in the area of the simulation data management. And then we'll talk about these 2 products specifically. So a quick overview of the software. So the key benefit of the software are SDM solution. Obvious reasons are standardization of the data and the processes. Documentation of all the services, and that's a very, very key, as we all know who been in the virtual product design development, the massive number of the runs we do, whether we are doing the crashworthiness, safety, or NVH, durability, number of the iterations, keeping track of everything, how everything is going to be organized, who is responsible for that, who touched this file, what is the design stage is. I know many companies doing a lot of Excel sheets to figure out, what's going on, but we know that is not the right way, and it can be destroyed. And also, one of the things that I learned is if somebody leaves, there is a huge potential that some of these documents and the activities will be missed also. Quality, it's important to have this automated model checking, so the processes and the quality of the models that is going to be base and the base of any type of the simulation that needs to be automated, and make sure that is stay standards as for throughout the product design development for all the products. Collaboration between the teamworks around the world, that's key, as we know, especially in this day and age, and because of a lot of work is done by offshore and different places and the suppliers. And basically, our product SCALE can bring and put an umbrella on the top of everything. So time saving, obviously, that's a major key enabler, and also providing the saving for the customers from the time spent and figuring out different ways, and finding the workflow around the world, how you're going to just manage your product. And at the end, there's a transparency for all the level of the engineering team. The project functions of the product is allowing different level of the people to attend and look at the projects and where the project is standing and the status of it from the very, very early to the end of the product design development. And this is a very, very key important of the product. And at the end, reporting assessment is always available. So jumping into the 2 product that we are going to be talking today, as I mentioned, project is an overview and an umbrella for the product design development that anybody from the top management the engineer who's working on that project. They can see where is the project, who's doing what, and basically who's responsible for different level and the task of the projects. And this is a very, very key and enabler, for anybody from the top management, middle management, and lower engineers to be able to define their role, responsibilities, and where the project is. SCALE model that Peter is going to be enabling, is going to be discussing that today is a key to set the stage for the product design and development. And SCALE results is it's a way that how to these results after all the analysis, whether we are using all the crash worthiness simulation, using different type of the products. It's allows us to enable a user to go through that. One of the key important things that I want to mention is our product is neutral, and we can use any pre and post processor or solver. So we don't have anything specific lined up. So that way we can use any pre-process such as hypermesh or ANSA or post-processing, as well as any type of the solver such as LS-DYNA or NASFN or everything else. So let's talk about project a little bit, just the overview. So I'll spend a minute in there, and as my time is getting run out. Project is enable you to define the responsibilities and milestone and describe requirements, provide tasks to every individuals. And also, model, it can allow you, that's basically what I mentioned a minute ago, that allows you to bring the model from any pre and post processor, bring the CAD data and the mesh, and prepare the model, define the load cases, and do all the runs and manage that while the runs is going and everything. Bring the results, post-process it anywhere that you want it, and then put it back together, get it ready for the results and comparison. So the results it comes right after your analysis is done, whether it's a LS-DYNA or any other type of the solver that you use. You bring the results, you start extracting it and managing the data, and the beauty of the product is you can bring all the tests that you have in the premises and do the test versus simulation and do the correlation and reporting at the same time. And finally, at the end, we are going to be looking at importing all the key results, monitoring the status of the projects from the get-go, and figuring out where it is, and get approval in the decision making and the projects, as we know, which is an important part of the product design development. A very strong point of the SCALE is they are cloud-based and on-premises. So you can just use it as a desktop in your office, or you can use cloud-based, and we are engaging with all the cloud-based product that is out there, and that's one of the key enabler for us. So being cloud ready, SCALE is for easy to use and customized, and we have a very strong team both in US and Germany that can provide you. With that, I'll have Peter to talk about SCALE model in the beginning, and then we'll jump in with the SCALE results. So with that, I will turn to Peter and have Peter to take us through SCALE model. And please ask your question throughout your chat. And Peter, please.
All right. Yeah, thank you for the introduction, Akbar. And also, hello and welcome from my side to all of the attendees. My name is Peter Friedrich. I'm Executive Vice President with SCALE.sdm in the US, and I'm based in Dublin, Ohio. So I'll be on the front lines of actually working with any of our customers in North America to implement the products that Akbar briefly touched on. And yeah, as the agenda shows, as the next section here, I want to give you a live demo of the SCALE.model client. So yeah, let's just dive right in, and I share my screen. All right. All right. Okay. Yeah, I'll try to keep this for those of you who have never had contact with with any of our products. I'll try to keep it very general and give you an overview about most of the features. But hopefully we can get into a couple of details just to give you an idea of what might be possible or in which directions other clients might be going or what we are actually developing in-house. Yeah, so what you see here is the main user interface for the SCALE.model client. So that is actually a desktop application that runs on Windows and Linux, usually all kinds of Linux distributions that are used professionally. And the reason why that's a desktop application in contrast to just a web application is that we need to integrate with a lot of the engineering tools that are already in your tool belt, like preprocessors, post-processors. You might even want to run some custom processes on your workstation. So you already have a workstation set up, and we provide a platform to synchronize with a centralized database so that you still can collaborate with your colleagues on the same project. So you still see each other's changes, each other's models, but you have more quality of life when actually editing those models by caching them on your local machine. So let's just start at the top here. The user interface can get kind of busy. So starting at the top, we see like a tab list, a tab bar, pretty common to what you might have on in a web browser, and we can open basically every part of the SCALE.sdm platform is integrated as a tab here. So we can open a new view to the results side, to the project side, or what we have open here right now to the model side. So if I open a new tab here, that's completely empty. And my first step would be to actually select a new project or a project that I want to work with here. So I would I see all the projects, or as we call them, pools here. I might use one or the other through the talk, so bear with me. You see all the projects that are available on the centralized database and that you have access to. So there's already permission management built in here. So you only see what you actually have access to, and you can select any of those pools and start working by selecting which model state you want to have as your baseline. So by doing this, that downloads some of the data to your local machine, not all of it. Usually data is loaded as you need it. So this process should be as quick as possible. and then you can start right with the working with your model. Let's continue with the rest of the navigation here. So on the left side, that all handles how to move through your data. So let's just close a couple of those first and start with the browser section here. This is what's called a rail graph. So you see every line in this list here is basically a complete state of your model. That might either be from yourself or from one of your colleagues. It can have different states, so those are the different icons. But I can move around, and basically whenever I click on one of those entries here, my entire application switches to use that state of the model. You might have noticed the lines or the actual rails here to the left of those names, and those show the relationship between different versions. So if I look at the version I'm currently at here, 2252, then I see that there's a straight line going back to 2249. And what that means is that the version I'm currently in was derived from this earlier version. So you can see how the different versions are related to each other, and also if there are any model states from colleagues that might be parallel to yours, or that others might be working on. If I scroll all the way to the bottom here, this list actually ends pretty soon, just to limit the amount of data we have to download when you first open the application. But you can always go back as far as you want by clicking any of those, and that will get more data from the service, and you'll be able to look at everything else here again. You might also notice that for each of those entries here, there's some text here. So that's a comment that you always have to set whenever you make a change. So this makes it easier to track certain changes through the history, and also communicate with your team members what you actually did in a certain version. You only see the first line here, but there's actually you can have that comment as long as you need it to be. So there's potential to have some structured data there as well. But for the quick navigation, it's useful to have just a short description of whatever you had, or whatever you did in that certain version. Also, right next to this, you might see those icons here, the R and the S. That is what we call tags. So this version, for example, has a reference tag, meaning that in the usual life cycle of a project, you might want to highlight a few versions that correlate to certain milestones, and you can use those tags to make it easier for others to find certain versions. Then just to finish up the rail graph here, there's also there's a filter feature in there as well. So if you're looking for something very specific, like maybe a specific change that was mentioned in the comment, or you might also just be looking for versions of a certain team member, or maybe you're looking for versions that have a certain tag, then we have this filter view that has a pretty extensive language to do some structured searches. So I could just start typing for a full text search, or I can also do a search for certain tags, and that returns me only the versions that match that rule. In that case, I only thing I want to see is all the reference versions, and that gives me another way to navigate through the entire project here. Okay. Yeah. If we move into the middle, you might have noticed that whenever I clicked something, the contents on the of the grid in the middle here changed, and according to what I clicked on. So in the middle here, you see actually all the model content. Yeah. So the crash model for this Toyota Yaris is split into individual include files, as you would have in an actual model as well. And then each individual include file is captured as one line in this grid here. This makes it, first of all, that's makes it easier to manage a bigger model by splitting it into smaller chunks. And also that enables you to work on a specific part without interfering with other people, or to make it easier to track changes to certain parts of the model. And in addition to just the file, so those are store more information than just the file. So we also, if I move to the right side here, we have a number of properties that are attached to every single component here. Those can be very basic information, like who modified it last, who created it, but also there is some more metadata attached to it to decide which load case it will belong to, but that's something I'll touch on later. Also, if I select an individual component here, you might notice there's another history view that's similar to the one on the left. So we also have the trackable history for individual components. So you see who changed a certain component, which changes they made, and then I can use a different version in my model if I need to. We can also look at multiple components here at the same time. If maybe I want to compare two similar components, then I can select them both. And in the properties here, that might not always be very helpful, but at least I see which of those values actually are the same, which are different. So it gives you another way to explore your data here. Okay. All right. Yeah, moving one section down in our navigation here. Look at this group stage that is basically represents the data structure of all the model parts that are in this database here. So just to make it easier to find certain model parts if the models are bigger, we have a hierarchy of groups set up here, and whenever I select one of those groups here, my viewport changes and only shows me what is actually in that group and below. So if I'm looking for something very specific, then I can tailor my view to only a small part of the entire model. Those groups here are completely customizable. So usually when you set up a model, that's one of the first things you would do. And you can have as many groups or as many hierarchy levels as you want to. Okay, one more thing I wanted to show with the you can do with the versions here. So I guess a lot of times you want to actually find out if there are any changes and what changed between two different states, or if you're working on something and you know a colleague works on something similar, then you might want to compare what they're doing. And one way to achieve this here is I can actually calculate the difference between two pool versions here. So if I do that on those two examples here, that generates a view of all the components that have been changed. Everything that's the same is not displayed here, so you only see what's differing. And you see with the color highlighting here from which version might be newer. And so, for example, in my doors and lids here, that was changed in both versions actually, but this one is the newer one, at least according to the time history here. So you have a quick way to find out what's going on. You can also, from this view, display a diff between the actual files. I'll touch on editing a little bit later, but if I just want to see the differences in the text editor here, I can bring up that view. And then I actually see that those two components in those two model versions differ just in this one line here. And I mean that's an example with just a text editor, but the same is also possible with maybe some more advanced diffing tools, like ANSA has model comparative capabilities, and those could all be integrated here as well. Okay. So next thing I want to look at is how to actually work with your model. So what we had until now is basically mostly navigation. So now to actually work with your model, there is we can integrate with a lot of preprocessors, basically everything that you already might be using. We either already have a script for that or can easily adapt one. And then the way this works is you would right-click directly on your component, and then you have this edit with dialog, which gives you all the applications that you have installed and configured on your machine. And if I do that with ANSA, so here it will download the file from the service if I didn't have it already. It will write this file to my actual hard drive, and then it starts ANSA with that file loaded. So that's all done in the background currently. Hopefully I get an answer license. Looks all right. And then my actual key file here is loaded into answer. Yes, let this finish loading for a second. And basically now I just have a regular preprocessor session. I can do whatever I want to change my model. I'm just gonna do one example change here, and just delete a couple of elements. So I made my rather crude change. And then we have some user script buttons here that come with the answer integration. So I can save and choose save and quit here, which will automatically export the key file from answer and then brings me back to my SCALE.model client. While answer was open, the SCALE.model client watches the file that it had written out. And now that answer has been closed, it notices, okay, there were some changes made to that file, and the users asked to specify what they changed. So here I have to give that a comment, change for webinar demo, and this way I documented my change, and also by doing that I created a new version of the model that I can make further edits to without interfering with anybody else's data. Okay, so I have my new version up here with my changed component. And yeah, the same is also text editors are also quite common to be integrated, or other pre-processing software. There's a lot of flexibility here. Going back to the data structure here, you might have noticed earlier when I was going through those groups here that there are a couple of different types of entries here. So in addition to your regular groups, this folder icon, there's also this database icon here. And this is what we call a subordinate pool or a mounted pool. And that allows you to have a library of usually maybe include files, maybe scripts, maybe session files. You have a library of those components, and you are able to use them in different projects. So in my case here of the materials, we have the same for barriers as well. We only maintain one single source of truth with our barriers here. And then for each project, you can just mount those, mount that pool. And so it's easy to always have an up-to-date version of your maybe auxiliary files. You can also, if you have a dedicated team member who maintains those, maybe the barriers, maybe the materials, you can take a look at those just in isolation. So if I go to open a new model tab here, that brings me to a new tab where I'll only see my barrier includes here. Go. It's clicked. Okay. Then going to the last part of the navigation here. This is where all the different load cases would be defined. So a load case is what we call a run or a run configuration. And that is basically it's a description of certain properties to select which include files should be part of a simulation. So to make an example here, I have my runs categorized by some attributes like the regulation here. And if I go to one of those, then what I see is my run configuration here specifies a certain angle, certain barrier, a certain impact location, and a lot more of those attributes, which are defining markers. And then for each model part or component in my pool, I would also set those attributes accordingly. So if I look at the barriers here, if I deselect my run, I have all those barriers set up in my pool, and each one of those is marked with a different attribute. So whenever I select a run, the logic is applied here, and only my rigid wall barrier actually stays active. I can also show all the components here, and all the green ones will be part of that load case, and all the red ones will not be in there. So that gives a lot of flexibility to set up load cases. It can also get quite involved to get the logic right here, but adding new load cases is usually easier because you don't have to specify all the includes you want to have in there. You only have to specify your set of rules to create the simulation or the run that you want. Just I want to briefly touch on parameters as well. So in addition to selecting individual components, sometimes you might only want to switch certain numerical values for different load cases. So staying with the barrier, you might have a single barrier include that's in your shared library, and depending on your load case, you need to change the position of that barrier. And we have all the different positioning values stored in this table here, and then depending on what load case you're in, you can do the selection again. Depending on which load case I've selected, there will be one line in the table that actually defines the values, and then we use those in transformation cards, in other control cards, or in the model files themselves. And as you might see here, there's a lot of possibilities with arithmetic or other math applications that are built in here. So there's a lot of flexibility to set those values. Next step here would be to actually start a simulation. So we have integrations with, or we integrate with your HPC environment, either on-premise or in the cloud or anything in between. And so if you have your run configuration set up, all you need is one click on the assemble remotely here, and that will send this simulation to your cluster infrastructure and start the actual simulation process. Talking about process, in addition to the actual model, also we have all the different scripts. session files, other customizations that you need, all as part of your pool version. So if I go here to this tools group just to collect all of them, there's actually quite a lot of scripts in here for standardized post-processing, maybe some pre-processing steps, the actual communication with the cluster, and the actual solver start script, for example. So all those can be kept at the same place as the data is, and also you can make sure that everything is up to date and repeatable in that manner. So on the cluster, if I'm going to a script section here, on the cluster, all the scripts I have here that are part of my run configuration or part of my load case, just the same. Processing pipeline from within this database here. And there's a lot of flexibility here. Also, the integrations with pre and post processors, like I showed with ANSA, that would also be part of the script. So again, there's a lot of flexibility based on your environment, and we can integrate with almost every processor here. Once you started the simulation, you might see that at my bottom left. Let me move that around. My bottom left screen here, I can see a status update of my job. So I started a couple jobs earlier, and here I can see which process steps they went through. If I get any errors, I can make them visible here as well, so that basically the only just by using that job status view here, you have a good understanding of what might have happened to your job, if it's finished, if it's still running. I was actually hoping that those jobs would still be running when we do this demo here, because we also can give like a progress bar by parsing the solver output, so that you get an idea when your simulations might be finished. But all the information you see here is also completely customizable through the scripts I was talking earlier. And as the last part here to close the loop, once your simulation is finished, in our demo environment here, all the simulation data or all the result data is uploaded to SCALE.result, and we have a direct link between two applications. So if I'm just going to switch to my version that I know we had some good data on. So if I go to this one here, I can actually, let me do that over here. I can directly jump from my simulation within SCALE.model to the results on the results part, and this will just open in another tab. I go to this one, I see all the simulations that actually were done in this pool version for this load case. And if I choose show run results, then that opens a new tab and brings up the SCALE results interface right in within the application here. And there I can look at all the result data, the D3 pod file in that case. Can look at photos, videos that might have been extracted during post-processing, but that's all things we'll touch on later with the SCALE results demo. Another thing you can do here is to open the files directly. Unfortunately, I don't have a post-processor set up on my system here to open the D3 pod files. But if I open one of the text files here, they are downloaded and then opened on your system, and they are also cached in this this desktop application. Meaning, once you open this D3 plot file once, it will take a while to download, but then it's cached locally, so you can quickly refer to it again without having to worry where it's actually stored. So it's still on the central database, and you can open it on demand, and so can your colleagues. Okay, I think that was everything I wanted to show you today, and we're also pretty much on time, I hope. So with that, I want to pass the moderation to Ferenc for the Q&A session.
Okay, thank you. Thanks for the presentation as well. We do have a few questions, and maybe we start with the first one. There was somehow a technical problem that it wasn't seeable how you opened a file and what are the possible edit options with components. The context menu was missing.
Oh, that's too bad.
I think the context menu is missing if you're not sharing the entire screen.
I am actually. So I have a context menu open now. Do you see that?
Nope.
Nope.
Okay. Let me try to restart the screen share here. Okay. Let's try it again. Anything?
No.
Do you see a context menu?
Yes. Start with paste and ends with reload.
Perfect. All right.
It's not complete, but
I'll try to locate it so that it's actually on screen here. Yeah, so that's the context menu for on a single component, and in the edit with, here's all that's basically a list of all the scripts that are configured for external applications. And by selecting any of those, it will open the component, wait for you to make some edits in your editor of choice, and then after you close the edit session, you will get back to the SCALE.model client to annotate your changes. I hope that answers the question.
Oh, I think so. The second question was partially answered by Marco, but maybe you can comment on this as well, or Marco, you. It is related to lifecycle management, and the question was, can you auto-delete older versions based on a rule of time or a certain amount of versions past the current one?
Yes, actually, I misunderstood the question in the first place. One of the main features of an SCM system is to keep a clean history of everything that's done. So if you have a pool version, which Peter showed here, one goal is that anything in the published pool version is as it is and belongs together. However, what you can do, you can define retention rules. If for some policies or legal rules or whatsoever requirements you need to clean up stuff from your server, that the includes of a whole pool versions are removed depending on the rule. And defining these rules can be obviously on time, date of creation, but they can also depend on certain metadata that is associated with the includes or with the pool versions. So there are very complex rules actually that you can build up to delete stuff from the server if needed. Okay, I think that hopefully answers the question.
And maybe the person asking could give a quick feedback in the chat if the question has been
I
answered.
think he wrote yes, thanks.
Ah, yeah. Okay, yeah, that's good feedback. Ah, got it. Thank you. And there has been a last question. Marco answered as well a little bit. For material cards, is there already any implemented feature to automatically renumber curves tables or material IDs?
Yes, maybe some words for the rest of the audience as well on that. There are no, well, there are some scripts which we already provide for editing capabilities. Peter showed that also for opening stuff in answer and so on. However, you can also write scripts that are actually doing things on the data itself. So instead of opening it in answer, you can open it with a Python script, and the Python script does whatever you want with the data. We have written such scripts for other use cases, but not for renumbering material cards for a specific solver format. However, this can certainly be done. And if you already have scripts, you can even integrate that script in the SCM system.
Yeah, I just read. Okay, thanks. So I suggest that we open the floor. Maybe if there are any more questions, you can raise your hand as well and we unmute you in order to ask the question. Otherwise, I propose we simply continue if there are no further questions. That seems like a no. So Peter, the floor is again yours.
All right, thanks. Okay, so I kind of tried to build a bridge to the result side already at the end here, but now we want to take a look at that in a little bit more detail. I could just do that in a tab within the SCALE model client here, but instead I'm going to just use my web browser, since the SCALE results platform, that's actually a complete web application, so you can access it from any machine with a modern web browser that has access to the correct network. So when I open the SCALE results here, that's the interface I'm greeted with. Similar to SCALE model, there's a project I have to select. So in my case here, I've went with the Yaris again, and that basically gives me a view of all the simulations, tests, every piece of data that has been added to the SCALE result system here for that particular project. So usually that involves simulations from everyone who's working on the project. Might include some physical test information that's also has been imported here, and I have that all in my reach here. Again, since it's a web application, it works directly on the data that's on the server side. So everything I see here comes directly from the server, and also if there's new data coming in, that I also see that directly here, and the view will just refresh. There are a couple of UI elements here. I have them arranged in a certain way, but actually I didn't show that for model, but you can arrange those windows however you like and save that as a preset. If you have a preferred way to order things, you can basically do that however you like. Also, there is some more customization in this table view here. So you see there's actually a lot of columns that each refers to a certain maybe a certain key value or some property of a simulation that has been captured, and those can be set up in a preset as well, to make it customizable, so you only see what you want to see. You can also enable and disable columns to get this view exactly how you want. You can filter directly in the in those columns. So if I only want to see things that are simulations with the discipline crash, then I can filter by that value, and basically all you can imagine here. In addition to those filtering capabilities, there are also some quick filters that can be set up so that they're usable for everyone. So here I have basically similar to what we had on the simulation data side. We have that structured by region and by market here, and then I can quickly select. Maybe I only want to see the US NCAP here, and that gives me a quick way to only show the tests that I actually want to see. Okay, so now actually to look at one of those records here. So every line in the table is what we call a test record. Could either be uploaded from a simulation or could be from physical testing. And each one of those entries can have a number of attachments. So those could be videos, photos, maybe some log files, maybe some other files that had been extracted during the simulation itself. So in our demo environment here, we extract a couple of screenshots from the simulation results and maybe a fringe plot here. And you can look at all those attachments directly for every test that you select. There are also usually some numeric values or key values here that we can also capture here, and that also makes it easier to compare different test records or compare test records to physical testing results. Another important thing you might have are time series data or channel values here. So you can have a number of channels for each simulation, and then we can, actually, let me get a good example here. We can plot them directly from here. Can also select more than one. Can also select a couple of different test records, and then I see all their channels here in one view. I grouped it by the name, so I can plot the same channel for the different test records in one coordinate system, and look at that data here. Looks like my example wasn't that great because they're all more or less the same here. But that way you can explore your data pretty in a very flexible way. In addition to those, you might already have some standard practices to evaluate simulations, or maybe some things you would look at for every simulation. And there's a way to define what's called a report here. Just drag that to the side, and that is basically fully custom, or that's a web page in itself that shows me some key values, all the data we have in our attachments for every test that I select. So this will update automatically or dynamically. If I select 2 tests, it will compare the 2 in this in the same view and give me a quick evaluation of my results here. Same works also with comparing the actual physical testing to a simulation. So we have a physical test in here just as one of the test records. And if we look at the movies here, we can show those side by side. And we can compare the channel data and the measured values here in the same way to see how well they correlate. And yeah, those reports are customizable, so they can either be created by us, or you can do it yourself, or give that work to somebody else. It's the APIs are very well documented, and there's a lot of possibilities in those results, or in those reports here. There's one more thing I wanted to show with the attachments here. There's also we integrated a 3D viewer here. So if you, of course, you can't really show the entire model within a web browser, but maybe you have, or you maybe extract just a very small part of it that you want to look at, and we can display that directly in the web browser here. So if I look at this one that's reasonably small, I can look at 3D model here, and also show the deformation over time, or fringe some more data onto it. So that's a really quick way to evaluate just the model part without having to open the entire result file, which you of course also can do. So you can just reset the grouping here. So you can also just open the D3 plot file directly from your browser, but that means you have to download the entire file. And the advantage of those 3D models that are directly embedded is that they can also be used in reports without any further intervention. Some more integration with tools you might already have. You might have maybe some session files or any kind of configuration for a post-processor that already creates a PDF report, or maybe a PowerPoint template for you. And we can integrate those as well. So we have an example here of an add-on that creates a report with an animator session file that we have. And what that does is you select the tests that you want to build a report with, and then you have some options here, And in the background, that actually kicks off the actual post-processor running in the cloud here. And of course, it failed because live demo. I'm sorry. Let's just try that again. Which kicks off the post-processor, creates whatever you want it to create, in that case a PDF file here, and then displays the results and gives you the ability to look at this or download it directly. And that can be done with any kind of post-processor or process you have already set up. Okay, so now it loads the PDF file here, and this one was created by Animator, and yeah, you can use that as a template to build your standardized reports. Talking about add-ons, there's and those are there's a pretty extensive API available for to you. So you can build your own add-ons for certain tasks. There are no real restrictions on that, given that you usually have good access to the data. So it all happens in a data center. So there's no downloading involved. So there's there are a lot of possibilities to integrate with other systems or integrate custom processes you might have. One last thing I want to touch on is actually also an add-on here that we developed for data analysis. So I'm just going to take a couple of my results here, and I'm selecting some input and output values for a couple of simulations. Just gonna select them here and then send data to data analysis. And that gives me an interface to do some more investigations into the data itself. So just have a very simple example here. I'm gonna define my input variables, which would be barrier offset and vehicle speed in that case. Gonna define my output values for firewall intrusion and OLC. And then I can already look at some plots that might look familiar to some of you for correlation, sensitivity analysis. So there are a lot of predefined views here already, but you can also create your own plot with the data, do some trend analysis, scatter plots to explore your data. We can also do some further sensitivity analysis here. Let's see if no, it's quickly enough. And we also integrated with some meta models, so we can actually create a meta model with a TensorFlow here and use the data we selected to train that. We'll probably take a minute or two, but this gives you just a different, some more tools to directly explore the data you already have, and again with a centralized platform so that everyone has access to the same data. Yeah, and with that, I think I would want to close the live demo here. I'm just looking through my notes if I forgot anything important. Of course, there's a lot more to talk about. One thing I didn't touch on is permission management, but there's an extensive system to set read and write access for different team members. there's ways to integrate with existing authentication methods, if it's Microsoft or Google, or to integrate with an existing login infrastructure and synchronize with existing permission groups. So there are a lot of ways to tailor this exactly to your use case. Yeah, I think with that, we'll give it back to Ferenc for some questions and hopefully answers.
Okay. Thank you and congratulations to the presentation. You didn't raise any question related to SCALE.result. At the beginning of result, there's been one question related to CAT, which has been extensively answered by Marco. Marco, I don't know if you want to comment on this additionally. Otherwise, I suppose that we open the floor for further questions. Please raise your hand. And having a look at the agenda, I think, yeah, 5 more minutes to go. So Marco, I keep it up to you if you want to additionally give some comments on the questions.
The question was on how to integrate CAT files or CAT system, or the relation between the CAE data and the CAT data, and how to keep track of that. So on the one hand, there's the question how to integrate with PDM systems if you have PDM systems in place, and it's always a tough question, and I think my answer in the chat also reflects that. And trying to integrate, in my experience, to integrate a CAT system, a PDM system, by writing a direct interface is possible, but it's very challenging even for bigger companies, because the PDM systems always are very customized to the individual customers, and so needs to be customized. So the connection. So the easiest way that I can think of, or that we have used, is that we actually try, rather than integrating with PDM system, integrate with the CAT software itself, like for example CATIA or other CAT software that you might have in-house. And this CAT software sometimes already has a connection to a PDM system. So what you can do then is update and interface the PDM system from your CAT software, download the required files from your PDM system, and store them back, actually not in the PDM system, but into the SDM system. And then from there, you can open the CAT files using your meshing tool of choice, like Answer or Hypermesh, and start the meshing. And one good thing is, by this, you are keeping the CAT file as a reference also in the SDM system. So you're storing it twice, but on the other hand, you always have the reference, and from there you can probably also ask the PDM system for updates, whether there are updates on the CAT data or stuff like that, and update it also in the SDM system and start the meshing. And then you can keep the ANSA database files or the Hypermesh files directly related to the CAT files in the SDM system. And one thing you have to take care of also is, if you want to use metadata from the PDM system, like part IDs or whatsoever, you'll have to make sure that during the meshing process, this information is not lost, and this information is passed on into the solver files or even into the metadata of the SDM system, so that you can look it up from there as well. And within the SDM system, then you always have a relation between your data that you keep there. So you can see, okay, this CAT data belongs to this ANSA file, and from this ANSA file, I created this keyword files or solver files, and from that solver files, they were part of this or that simulation, which created certain results, and the other way around as well. We didn't show that extensively, but there is definitely the possibility you go back and forth between results and CAE data, and if you store the CAT files with the CAE data, you can have that also. Okay, hopefully this answers a little bit of that. If there are any more specific questions, you can always approach me or us, and we can try to elaborate it for your specific use case.
Okay, thank you very much, everybody. I'm gonna share my screen and basically just final closing notes. First of all, thank you very much, everybody, for attending this webinar. I appreciate your time. I know it's a Thanksgiving weekend, and I mean, Thanksgiving week is coming. I mean, happy Thanksgiving, and I'm sure you know everybody's planning. Again, thank you for your time. Just as mentioned, please ask any question that you have technically, or you know, for any specific demos that you like for your company. We'll be happy from the US and German side to organize that and have a demo specifically for your company, understanding your platform, your environment. We'll be happy to come and visit you physically to your office and figure out what is your need and tailor the product to your needs. Please contact myself, info@eSavant.org, or Peter at info@SCALE.sdm US. And my email is also there. As far as the getting the demo, a potential demo for the product, we'll be reaching out to you for evaluating this webinar. And those of you who answer the evaluation will provide a demo for SCALE results, so you can just play with that in the meantime. Anyways, I want to again thank you, everybody. Thank you, my colleagues. Thank you specifically those friends that reach out to me and you know, wanted to get participating in this webinar. We look forward to talking to you soon. Hopefully, you know, part of this year and maybe early next year. Happy Thanksgiving, and thank you very much. And I'll see you later. Thank you. Bye.